Hi friends, welcome to my channel Power Plant Act. Once again, myself K. Padmakar inviting you my new topic air flue gas steam circuit in boiler. This topic is very important for the person those who are engaged in power plant operation and maintenance. I am going to explain this topic with a block diagram as shown in this, and this diagram is based on AFBC boiler. Let us start the topic. So I will explain the circuit of air flue gas water steam cycle, how it is going to be functioning in FBC boiler. Okay, first of all, there are the three fans are provided. One is ID fan, which is called induced draft fan, and second is FD fan, that is forced draft fan, and third one is PF fan, that is primary air fan. So air at ambient temperature around 30 to 40 degree temperature is fed to FD fan, and this air is increasing up to 700 to 750 mm WC, and it enters to air preheater. Okay, in air preheater the function is like this. Flue gas enter from the bottom of the air. In the air preheater there is a number of tubes are provided. At the bottom of the flue gas, at the bottom of the air preheater, flue gas enters, and again after passing flue gas inside the tube, it exit on the top of the air preheater, and this air of cold air or ambient air enters at the top of the air preheater outside, and it exits outside. So it enters at a temperature of 30 to 40 degree temperature of air, and it comes out with a temperature of 120 to 130 degree temperature, and flue gas whatever it is entering is around 220 to 230 degree temperature, and comes up to 130 to 140 degree temperature. Okay, so the temperature of this air, whatever it comes out from air preheater 120 to 130 degree, is very significant, because the raw material used in boiler of coal is contains volatile matter, and this the ignition temperature of this volatile matter is very particular, because this temperature is around 200 to 250 degree temperature. If you increase the temperature of this air outlet of the air preheater is around 200 to 50 degree temperature, then what happens? This coal takes ignition inside the coal nozzle, and this nozzle gets heated. So we have to take care of this temperature up to 120 to 130 degree temperature. For controlling this air temperature, one control valve is provided in the circuit. This is cold air is passed, so you can control this air temperature by opening this thing. Okay, then this air, the pressure from air preheater, the air of the pressure of the air from outlet of APH is around 650 to 700 mmWC. That means it enters APH at a pressure of 700 to 750 and comes out with a pressure of 650 to 700 mmWC. Just slightly this pressure is going to be reduced. Then this air enters to wind box of the boiler. The main function of this wind box is to fluidize the bed material provided in the furnace of the boiler, and second is combustion of the coal inside the boiler. So this is the air provided to, hot air is provided in wind box, and the part of this FD air is provided to PF fan. In the outlet of the PF fan is pressure of the air is increased from 650 to 700 mmWC to 1100 mmWC. That means pressure is increased in primary air fan, and this air is feed to coal nozzle. The coal nozzle that means construction is something like this. This is this is called convergent divergent nozzle, in which the pressure of the air is going to be increased. In the convergent zone, the pressure is reduced and velocity is increased. In the divergent zone, this pressure is increased and velocity is reduced. This is the principle in coal nozzle applied. So while this air enters here and coal comes on top, and both coal and the air goes to boiler. Okay. It enters, and this is the circuit of the air circuit. Okay. Then second we will consider the flue gas circuit, how it is functions. After taking combustion of the coal in boiler, if flue gas is going to be generated at a temperature of 700 to 800 degree temperature, and the temperature inside the boiler of what you call bed material is around 800 to 900 degree temperature, and air velocity is around 2 to 3 meters per second. Okay. Then this flue gas of 700 to 800 degree temperature enters in superheater zone. In superheater zone, the flue gas temperature is reduced around 250 degree temperature. Okay. So when you are when this 700 to 800 degree temperature flue gas enters in superheater, the outlet comes out with 400 to 450 degree temperature. Then this flue gas enters economizer. The economizer is constructed in such a way. Flue gas inlet, and this is a flue gas outlet. Okay. And this is a header. There is so many. I am showing only one coil, but there is so many coils are there. It is inlet water, and this is outlet water. So when the flue gas temperature of around 400 to 450 degree temperature enters, and it comes out with a temperature of 220 degree temperature, and feed water inside the economizer enters around 120 degree temperature, and it comes out with the temperature of 220 degree temperature. Water is going to come out from economizer. Okay. Then this flue gas, after coming out the flue gas from temperature of 400 to 450 to 220 to 250 degree temperature, outlet of the economizer, flue gas temperature, then it enters to air preheater, where already I have shown in air preheater the flue gas temperature enters is 220 to 250 degree temperature and comes out with 130 to 150 degree temperature as shown in the flue gas inlet and flue gas outlet. Okay. Then it enters ESP, that is electrostatic precipitator. This is a device or this is an equipment of pollution control related equipment, where this SPM, that is particular matter, is to be maintained in this around 50 milligram per nm cube. This is standard what you call SPM, that is particulate matter. In that means whatever the ash particle present in flue gas, it is to be reduced up to 50 milligram per mm cube as per pollution control board. And the principle applied in ESP is nothing but there is a series of collecting and emitting electrodes are provided alternatively, and these emitting electrodes all are charged with negatively charged, and these collecting plates are charged with positive charged. This is emitting is charged with negative, and collecting plates are charged with positive. Okay. When these are negatively charged, the ash particles in the flue gas are going to be ionized, and it makes negatively charged, and these negatively charged ions of these particles is going to be attracted by collecting plates, and these particles are dislodged periodically. Okay. This is the principle applied in electrostatic precipitator. Then this flue gas enters in ID fan. After that, it goes to chimney. Okay. The flue gas parameters is like that. The furnace temperature in boiler is maintaining around -1 to 0. That means around negative to balanced draft is going to be maintained in boiler. And in superheater, the draft is nearly -5 to -6. It is going to be maintained. And in economizer, the draft maintained is -10 to -20 mmWc. And in velocity of the furnace in boiler is around 2 to 3 meters per second. And at superheater, the velocity is around 5 to 6 meters per second. And at economizer, the velocity is around 6 to 7. And at air preheater, the velocity of air is flue gas is around 13 to 15. After entering in ESP, this velocity is suddenly going to be reduced because it is going to be expanded suddenly. So the velocity is going to be reduced in ESP, and the velocity is less than 1 meter per second in ESP. Then it enters the ID fan like that. Okay. This is the flue gas path. Then I am going to explain water steam circuit, how it is going to be functioning. Okay. Actually, the temperature in deaerator is around 120 degree temperature. You may aware of what is deaerator, where feed water is going to be increased up to temperature 120 degree temperature. After that, there are 2 to 3 boiler feed pumps are provided to extract water from deaerator. And after that, there are 3 control valves are provided. This is a control station water, feed water control station, what they call it. And here 3 control valves are provided. One is 30%, and second is 100%, and third one is bypass. In 30%, this control valve is operated of this 30%. When the boiler load is below 30%, then this valve is going to be operated. When the boiler load is 100%, when it is fully loaded, then this control valve of 100% is operated to get optimized water from deaerator. And third one is bypass. When these 2 valves are not operable, when there is a problem, then this bypass valve is going to be operated. Okay. Then it enters to economizer. Before that, there is a control valve is there, which is called economizer inlet valve. So this temperature of feed water around at 120 degree temperature enters in economizer inlet, and hot water is going to come out from economizer with a temperature of 230 degree temperature. The water extracted from flue gas is called a sensible heat. That means there is no phase change. That means if sensible heat means only temperature extracts from flue gas, whereas latent heat means there is a phase change. In economizer, only sensible heat is gained by water through flue gas. Okay, then it enter to steam drum. In the steam drum also the temperature is around 250 to 300 like that. Then it enters economizer. Then from steam drum this water comes to furnace through downcombers. This is downcombers means there is a pipes are provided which is called downcombers into furnace. Furnace of this bottom ring header, and this furnace is like this. I will show it. Okay, this is bottom ring header, and this is a top ring header. So water from downcomber, first it enters to bottom ring header. In after that this water enters to water walls of the boiler, and in AFPC boiler there is what you call evaporator tubes are provided inside the boiler, and it also enters the evaporator tubes, and it comes out with the top ring header. Again it comes up with the top ring header. After that top ring header, 1 minute, it enters once again to steam drum through riser tubes. What you call it, riser tubes it enters. Okay, in steam drum what the functions takes place, it is a separator is provided inside. The steam separator is provided where steam and water is going to be separated in steam drum. Only saturated steam comes out and water retains inside the steam drum. So this saturated temperature around 300 to 310 degree temperature enters primary superheater. In primary superheater, actually this temperature 300 is the saturated condition. That means some amount of moisture is present in the steam. In primary superheater, the function is to remove all the moisture content in the steam. So it enters to the primary superheater, and the outlet of the primary superheater temperature is around 350 to 360 temperature, and this gains from flue gas only. It gains the temperature through flue gas. Then it enters to attemperator. In attemperator, the function of the attemperator is to control the temperature of the steam, and the media for controlling the temperature is feed water, and it is taken from boiler feed pump outlet side. Okay, after attemperator, the steam enters secondary superheater, enters, and after that outlet of the secondary superheater is 490 degree temperature, because the boiler rating is 66 kg per centimeter square, and 490 plus or minus 5 degree temperature rating of the boiler. So this temperature of this steam temperature is maintained with attemperator, and this temperature is maintained. After that there is MSSV, that is called main steam stop valve is provided. The function of the after that this steam goes to turbine. So this is the water circuit. Okay. After that, now I am going to share an important thing, that these economizer, air preheater and superheater, these are called auxiliaries of the boiler. The function of these accessories, not auxiliary, accessories. The function of these accessories is to increase the overall efficiency of the boiler. In economizer, the heat absorbed by economizer, this water from flue gas is around 20%. In superheater, the temperature extracted by steam from flue gas is around 10%, and in air preheater, the air extracted from flue gas is around 10%. So total 40%, 20, 10 and 10. Total 40% heat is extracted from flue gas. So suppose the boiler efficiency is 90%. Boiler efficiency is 90% with accessories of these three. Suppose you think that these three are not provided, then the boiler efficiency comes down 50%. That means 40% is reduced, the efficiency is going to be reduced, and it comes down to 50%. So this much of importance is there of these accessories. Okay. The others are all same as. So I think I have explained this cycle with my satisfaction. So if you like this video, then please please subscribe my this power plant act and like my video. Thank you, and thank you very much.